with you, babe. Go with you, babe.
Ladies and gentlemen, welcome to TFI CAD Tips, where on today's show I'm going to be plagiarising someone else's work. I'm not really, I'll be giving him full credit. And that guy is Tanner Reid from the Autodesk Fusion 360 team. He's done this really quite clever tutorial on Fusion 360, modelling up the Fusion logo. Now Tanner, he's done a really good job. He's one of these sort of millennial, yuppie, hipster kind of guys who uses words like leverage and workflow and productivity and geometry far too often. But I'll tell you what, he's done a really good job in this tutorial. You can find it on the Fusion 360 YouTube channel. So he's modelled up the new Fusion logo, which is one of these abstract art type affairs. And all of the products have actually had a new revised logo. So using T-Spline services, what he's done is he's patched up the regions. You can see here, I'll just let the video render. And then using all the services, increases them all together and then converts that into a solid. Sort of raises a couple of the regions up and then converts that into a solid and then creates a final render towards the end, looking a little something like that. So he's done a really good job. It's a very good tutorial. So what I'm going to do, I'm going to stop watching all the Fusion 360 guys waving their penises and dicks in the air, giving it all whoop, 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 look how great Fusion is, isn't it? Like, so futuristic and amazing. And I'm going to be like, whoa, just put your penises back in your pants. Just calm down, because Inventor can do all this as well. So what I'm going to do is I'm going to show you this exact tutorial, almost step for step, in Inventor. So if you're using Inventor and you're seeing all this noise coming out of the Fusion team and you're like, I'm missing out, man, that looks really good. Well, you can do it as well. You can do almost everything. You look at all the tutorials that are coming out, fan blades and trainers and flipping screwdrivers and all this kind of stuff and bloody wood cabinets and that and bookshelves. Hey, that's what Inventor's for. Don't give in to the hype. Right? Don't believe the hype. Fusion's a great product, but Inventor is king of the castle. This shit's Justin Bieber, we're Frank Sinatra. So let's get cracking. Now what I'm going to do, honestly, I'm not even joking you. This is probably the 30th, I'm no exaggeration, the 30th time I've tried to do this tutorial and I've had to start it again. You can probably tell by my voice. And I'm making a completely different approach to it this time. I'm not going to make this like a training tutorial where I'm explaining what it is that I'm doing as I'm going, because it took 45 minutes on one attempt. And that's just far too long, and it's very difficult to explain what I'm doing. So instead, what I'm going to do, I'm going to just do it from scratch. You can watch me doing it, and you can follow me, but I'm not going to sort of stop and explain what I'm doing, because it's so fiddly, this one, because I'm copying someone else's work. And full credit to Tanner for that. Like I said, all credit to what I'm doing here is going to go to Tanner. I don't really want to explain it like it's my work, so that's the reason why it's going to be a little different to all the other tutorials that I've done in the past. So what I've started by doing is going to just Google Images and getting this, I just did a Google image search for Fusion 360 logo, and I've grabbed, I think this is actually Tanner's thumbnail from his YouTube video, and I've cropped it off and saved it as an image. So I'm going to bring that into Inventor as sort of a background canvas. That's what these sort of modern graphical artists do. And also, when you bring in images in, never link your images. You're in for a bad time if you do that. I said I wouldn't explain things as I go along. I might do. Hey, it's my gig. I can explain it if I want, but I'm probably not going to. I'm going to stop there. Right, so yeah, never link your images. Always embed them, and we're going to drop that in and place it on here. So yeah, that's what all these graphical artists do. They bring in sort of canvases and use images as blueprints in the background, and that's I guess that's fair enough. But Inventor does lack on that side of things. Inventor's got some shortcomings when it comes to working with images. So one of the things that Fusion does that Inventor... Come on, pick it up, there you go. One of the things that Fusion does, which it does it better than Inventor, is working with images. Fusion can make your background images here, like this one here, it can make it transparent so you can see through it and it doesn't get in the way. With Inventor, you just can't do that. It's just really annoying, but it is what it is. Some work for the Inventor team to do there. But you know, what can you do? You just got to work with what we've got to work with. So because we can't see through the image and it's going to get in the way if we put our surfaces on that image, I'm going to offset this plane by 10 mil. And because it's the plane that I'm going to use throughout the rest of the tutorial, I'm going to rename it in line with this millennial type of speak. Do you even T-spline, brah? And that's what we're going to use for the rest of the tutorial. So let's get cracking. So I'm going to be using the freeform tools throughout this. The freeform tools, you'd normally with freeform in Inventor, you normally start off with like a primitive, a box or a sphere or a cylinder, because it's sort of product design, isn't it? You want to start off with a solid. Most people that use Inventor are used to solid modeling, so you tend to want to start off with a solid, but we're not going to be using any solid primitives in this example. We're always going to be using the face command. And whenever we go to the face command, you're always going to be clicking this work plane as well, because you want to restrict all the points on your faces to this plane. You want to make sure that everything is, in terms of 2D, restricted to that face. So it's not above or it's not below. And that's where I'm coming from there. So we're going to go for a multi-sided face, and we're going to start with this region here. So there's going to be, I'm just going to have to essentially fill in time as I'm going. If it even lets me click. No, it's not. Did I click that work plane? I didn't click the work plane. That's why. Right. So let's start that again, because and I tell you what, like, if I make mistakes in this, I am not starting this again. You can't even begin to understand how sick I am already of the sight of this bloody F. I've been going on it for about 3 days, and I'm like, I'm over it. I'm just going to do it. If I make a mistake, I'm just going to cancel it and just keep on going. So I'm going to make sure I did click that work plane, and we're going to go for a multi-sided face. And then we're going to start with this region here. So this is the point where you're going to lose sight of my cursor, which is really annoying. And I don't know if that's Inventor or my screen capture software. I think it might be Inventor, because it seems to be fine in all other examples. But yeah, in one of the videos, probably attempt 26, I was sat talking for about 5 minutes, pointing at things with the mouse cursor. And when I rendered it back, I actually rendered the final cut of the video, and I just couldn't see the mouse cursor. It was me going, oh, I was going, oh, and over here, and down there, and just couldn't see what I was doing. I was pointing at nothing. I was like, oh, for flip's sake. Anyway, right, we're going to subdivide this into maybe halfways like that, and that gives us a center point to work with here. So this is what I'm saying about, I'm not going to explain what it is that I'm doing and the methodology behind everything, because it just took so long. So you can follow me as I go. And I mean, this is essentially what I did with Tanner's video. I just followed him as he went. And you can kind of understand what's happening as you're following. You don't necessarily need somebody to tell you. It's sort of like an idiot's guide to what is going on. I'm sure most people that are watching this have got a brain in their heads. You know, you can figure out what is actually happening pretty well without it being explained to you word for word. So that's the first section of faces done. You can see what it's done. It's pulled them off the edge. So I actually did snap these points to that semicircle, but it's pulled them off as it's rounded off the faces, which is fine. We can use edit form. We can do a point vertices selection. We can just grab those up and then just sort of pull them around. This is what they do in the fusion. This is what they do on the fusion videos, and it makes them look all modern and millennials. Like, yeah, look at me. I'm just conceptually dragging things and just capturing the design intent and my workflows. I'm leveraging the technology to capture my design intent. Sorry, man, come on, give it a rest. Right, and then we're going to work on this section of surfaces up at the top. So these are all flat as well. So we're going to go for another face, restricted to that work plane, multi-sided faces, and then we're going to start on this region here. So working with T-spline surfaces, it's not exact at all. It's all in the name, isn't it? It's freeform, you're freestyling. So you can't snap to the images, you can't constrain any of these points to the images. So in a way, that's actually good, because it kind of takes some pressure off. So you're not, because you know you can't be precise at this point, you're kind of not as worried about making mistakes and it not being perfect, because you can't be perfect. There is no way to make any of these faces absolutely smack bang on the image. So you can just, it's like I said, it takes the pressure off and you just feel more at ease when you're doing it. And also, at any point, you can just cancel what you're doing and then go to edit form and then pull the points around and correct it. Just move them around and tidy them up. So I love freeform. I mean, freeform is an absolute revelation. Personally, I don't think this bloody module has been given enough credit, if I'm honest. I don't think there's been enough singing and dancing about this. The Fusion lot have been singing and dancing about it. I mean, just look at the bloody tutorials you've got going on YouTube. But Inventor's just sort of quietly adopted it, and it's been like, yeah, you can do freeform now. Yeah, it's been tweaked a little bit in this version. And it's like, I think you should be singing and dancing a little bit louder and a little bit more funkier than we have been. But I can't guarantee as well, I was just thinking there about versions of Inventor. I can't guarantee that everything I'm doing here will work on earlier versions of Inventor. I'm using 2017, which is the current one as of today. But if you're working on an earlier version, maybe 2015, I can't guarantee that everything is going to work in the exact same way. The only thing I can really do, I mean, I haven't got time to look at everything on every version of Inventor, obviously. I mean, nobody's got time for that. But you just have to just give it a shot and see if you get stuck anywhere. And if you do get stuck anywhere on an earlier version of Inventor, then it's a good opportunity to then try and figure out and work on some workarounds. So right, we're now going to do this gradient face here. So if you look at the F, so we've got this flat face, they're on the same elevation as each other, and then this face sort of gradients down to a point, or to the edge running down there. So to do that, we're going to have to work up here, and I'm going to start by creating... See, this is again where you learn from experience. I know, because I've done this 30 times previously, that if I try and create a polygon up here first, Inventor's going to refuse and it's going to block me. Watch this. So I'm going to try and create this polygon here. And Inventor says, no can do. Doesn't let me do it. It must be something to do with how it needs to blend this surface in with the rest of them. And I think it might be because if we look at the way I'm... Oh, bollocks, missed the end point. If we look at the way I'm making this surface, let's go for a multi-sided polygon. Start from there, coming across there. This new polygon is attached to the rest of the faces by 1 point. So it's having trouble blending those two together. Which is fair enough, So what I'm going to do instead is I'm going to start down here. So I'm going to create a polygon around here, which is attached to an edge. So this polygon here is adjoining the section to the right-hand side via an edge rather than just 1 point. And that should be fine. It should be all right with that. And then we can work up from that point. So let's come, I'll say around about here. I think, oh shit, have I made a 5-sided surface? I think I have. Doesn't matter. I think we're fine. I think we might be fine. This one's going to be a 3-sided polygon just to close that region there. All good. Right, let's crack on. So we're going to come down. And it's just, I mean, that's why I'm saying I don't really want to explain what it is that I'm doing. Because a lot of it's just repetitive clicking points and making a sort of repeat polygons. So I'm not too worried about that. So if you are following along, don't worry about it. Don't worry about what you're doing being absolutely identical to what I'm doing. It doesn't matter. If you've got more faces, if you've got less faces, it doesn't matter. If anything, it's probably going to be a good thing if you don't do it absolutely identical to me, because then you'll start to see with your own eyes what differences you'll get if you've got less faces or more faces. Because the more faces you've got, every one of these intersections here, so you've got a point there. Oh, you can't see my cursor, can you? Bollocks. But if you look at the lines, you see where you've got lines meeting and then crossing over each other. It looks like a spider's web. Well, each one of those points and edges is a point where you can actually edit the polygons and pull them around and move them around. So the more faces you've got, the more scope you've got to fine-tune the surface later on. So it's not necessarily a bad thing to do it a little bit differently. You will learn from whatever it is that you do. So this is going to be the last section. We're just going to come to this point, and then what you're going to find is when I finish off this polygon, it's going to round off the corner, and that's not a good thing. That's not what we're going for. It's kept the hard point up here, but down here it's sort of curved it off, and I'm not happy with that. So what we've got to do is create a crease line running through. A crease line is you telling Inventor, I want you to maintain a single... Well, it's like a bend line, if you like. It's where it's a bend line running through the surfaces, and I want this line here to be a bend line. So to do that, what you can do is if you double click an edge with the left mouse button, Inventor will chain select the edges as best as it can. So you can see that I've double clicked that edge and it's selected by chain all of the adjoining edges. And then I'm going to go to the modify area and we're going to select crease edges, and that creates its bend line running all the way down through there, and then it retains that corner point. And that's now going to be a crease line. So happy with that. I'm happy with that. Right, the next thing I'm going to do is define this sort of middle region here where we've got it's almost like a canyon. We've got like a concave region where you've got a dip running through the center of where two faces meet. So if you look at this flat region, you've got this face here running off, and then that sort of gradients down, and then here gradients down, and it meets where that sort of, you can see the curved reflective light. So to help us with that, what I'm going to do is finish this, and I'm going to save the part because it can be as buggy as a bag of mosquitoes at times. So I'm just going to call this the Fusion logo, make sure it's saved, and I'm going to create a 2D sketch on our kind of common work plane here, the Do You Even T-Spline work plane, and I'm going to create an interpolation spline, which is going to be starting from, you can see, right, if you look at this F, we've got a hard edge here, and then it starts to curve around here. So I'm going to start the spline at around this point, and this spline is basically just a guideline. It's going to be a guideline to help me define the surfaces in freeform. And then I would say as this is blending around here, it's going to stop probably about there, I think. Okay, right, that curved spline doesn't look very natural, so we need to use these handles just to slightly alter the spline to put it where I want it to be. So I'm going to activate all the handles on the spline. So I'm just going to click these points, right click and activate the handles, and that's going to give me some grip points to just to pull the spline around and put it into the position where I want it to go. So grab the end points and you can just sort of bend the spline around. If you pull the handles, it'll kind of stretch and alter the curvature of the spline. And it's not an exact science at all. This is purely conceptual. I'm just sort of playing around with it until I can get it looking something like how I think it should look. So that's that point sorted. And then this point down here, we need to grab this grip point and kind of maybe pull it up slightly. That constraint's in the way. So let's grab this point. That'll do. And then finally this point here, I would say maybe needs to come up slightly. Get out the way. Get out of the way. Right, it's difficult to select it, but oh shit, don't right click. That's about right, I would say. Okay, so I think that'll do. I mean, it's not the most natural spline that I've ever made in my life, but I would say it's about right. It maybe needs just to come down slightly. That'll do. So what we can't do, if we go back to when we go back into the freeform area, we can't create surfaces which attach themselves to the spline. There's no link, there's no relationships between freeform surfaces and 2D sketches, unfortunately. So this is here purely just for guide purposes. And also, I don't know if the Fusion guys have this problem, but because I've created this spline after I've made the freeform feature, if you look at the historical browser, we've got the form and then we've got a 2D sketch. If I edit the form, you can't see the spline because it happens afterwards. So whilst I was making this, that sketch didn't exist. So Inventor just can't see it. So what we've got to do is just hold the left mouse button down on sketch 2 and just drag it above form 1. And then now when we edit form 1, we can see the spline. So like I said, I can't attach any faces to the spline. I made it purely as a guide so I can create additional surfaces that follow the light path, if you can see what I mean. So let's do some more faces on the work plane. We're going to go for multi-sided faces, and then we're going to create a number of regions above and below this parting line here. So again, we can't create curved splines, curved faces. So everything's just done with hard edges, which is fine. It's absolutely fine, really. It doesn't actually matter. But what does matter is where I'm going to finish this. I would say, I'm sorry, I'm just thinking out loud as I go. Will that do? I think that should do. And then let's come down here. This is quite a difficult region to actually get down because you've got this sort of curved line running up here, and it's difficult to get the straight edges to follow that line. But I think that should be fine for what we're doing. So it's good practice, though. It really is good practice. If you can get your head around what's actually being done in this example, you're on your way to being able to model almost anything you want in freeform. You really are, because it's such a good tutorial that Tanner's done. I mean, if I wasn't like being very careful clicking things, I'd give the guy a round of applause. Hats off to Tanner for creating a wonderful tutorial. So let's come down to about here, and oh, have I goosed that one up? Have I goosed that one up? No, let's go to there and let's finish that one off. I'm not happy with that one, but it shouldn't matter. It shouldn't matter. Let's just make this a three-sided surface. Yeah, that'll do. And let's finish this region off, coming across here. And then the three-sided surface along there. There we go. Right, so, oh, hang on a minute. I need to finish it up here. Right, 1, 2, 3, 4, and then there, and then one final triangle. So coming up here. I can edit all of these later on if I want to as well. Right, so when I click done, what it's going to do, it's going to blend all these together and round them off, and it's going to, again, we're going to lose our hard corner here on the middle of the F. But it's not a problem. We can just double click that line, hold down Control, multi-select these lines here, and we're going to do what we did on the other side of the F, and we're going to crease those. So we're going to create another bend line running around here, and that's going to give us our hard corners back, and there we go. Okay, because it's pulled some of these surfaces off the blend line, or the spline, the guideline, I suppose is what I should call it. I can use edit form to pull these points back into where I intended them to be. But because it's difficult to see the image, what I like to do is look at the rear of the image, just select the back of the cube, and then when you hover your cursor over the surfaces, you can see the white edges and how they relate to where they should be. So for example, this point here should be on the edge there. So you can use edit form to pick up these points, and then you can pull them back to where they should be. And yeah, I'm not actually too worried about it right now. For the purposes of the tutorial, I'm not too worried about it being a little bit inaccurate. As long as it's there and thereabouts, that'll do for me. And I can't see my spline again because the image isn't transparent. I can't actually see my spline through here, so I'd have to do that from this side. But I do want it to follow the path of the spline, because that was kind of the whole point in doing the spline. So I don't want to dismiss its purpose too much. So let's pull these back onto the spline line. Yes, I'm happy with all of that. I'm happy with that. Okay, right. What I should do as well is just pull this point down just ever so slightly. Maybe to around here. Okay, right. So that's that section done. I'm done with the spline. So the spline, I can right click on it in the browser and turn its visibility off, and then I can proceed with finishing off this this section of faces running through here. So let's just rinse and repeat. So we're going to do a face on that work plane, and we're going to create another series of T-splines around here. So if you're wondering what T-splines are, hang on a minute, that's ended badly. Let's just make sure I can get this surface. Right, yeah, that's done. So yeah, if you're wondering what T-splines are, if you're not too sure what the terminology is for T-splines, T-spline isn't really anything that you would have sort of got taught at school and you forgot. T-spline is actually proprietary technology which was designed by a guy called Tom Sederberg from, I think it's Brigham Young University. I don't know where that is actually, but it was designed by him and a team of, I think, 7 people in a university back in 2002. And Autodesk bought their company. Autodesk just thought, hey, this stuff looks absolutely fantastic. Tom and his team called it T-spline. And I think it was in the back end of 2011, Autodesk came along and said, look, we want your company. Tom and his team thought they were just wanting to license it, but no, Autodesk were like, no, we want to buy it. We want your company. And so back in 2011, I think it was December 2011, Autodesk bought the T-spline technology. And the first early iteration of T-spline servicing was in a product called Fusion. I think it was Inventor Fusion. I think it was its first name. It was a plugin for Inventor, but called Fusion. That's how Fusion 360 started. And it was absolutely horrendous. There was a button on the ribbon bar at the top where it was like launch Fusion. And you were just looking at it and going, what is the point of this, right? You would launch it. It would start a separate program altogether. And you'd be like in a completely separate environment doing all this T-spline stuff. And you'd be thinking to yourself, right, this looks okay. It looks good. I mean, this is stuff that Inventor just can't do. It looks nice. I like it a lot. But what's the point? What's the point? Because you couldn't do anything with it. Once you'd made all these sort of freestyle, organic looking surfaces, you brought them back into Inventor and you just couldn't do anything with them. So it was a very strange introduction to T-splines. And then over the years, I think Fusion 360 adopted T-splines before Inventor did. And that's kind of how it started. Yeah, so that's where the whole technology came from. This guy called Tom Sederberg over in a university, and I'm assuming he's now more considerably richer than pretty much everybody who's watching this combined after his company was bought out. Bollocks, I've just missed that point. Damn it. So I have to start that one again. Yeah, I'm assuming, I've got no real hard information on this, but I'm assuming that Autodesk have developed the technology recently since they've bought it and adapted it to the products that they've put it in. So, oh dear, right, we've got a problem at the bottom here. So I'm having trouble trying to get this final surface put down. I've now forgot which ones worked and which ones didn't. But sometimes Inventor does have problems putting down the surfaces, and you just have to try and approach it from different angles. So now it's right. Okay, that one's fine. So yeah, if you do have problems creating a face, all you've got to do is just make it in a different way, or start an adjoining surface and see if that helps. And normally it does, and in this case it doesn't. I have no idea why it doesn't like this one. If it doesn't let you create a face and you've literally got no other options, like I actually don't really have any other options here. I don't know what I'm going to do. Okay. Oh my god. I have no idea what's happened there. It just didn't let me do it, but then I clicked 3 points in different orders and it let me do it. Okay, whatever. Fine. Right, so there we go. So what we need to do now is create another couple of crease lines. So this line running down here should be a crease line. I want that to be a bend line. So I can double click and it hasn't picked them all up. So we're going to hold down Control and we're going to select this chain of edges running through here. And then that's going to be creased into a single edge. Crease edges. There you go. That's looking pretty groovy. And then one final one is going to be the middle of the canyon. We want that to be a creased edge. I'm not too sure this one's going to work. We'll give it a shot and see what happens. Nope, doesn't like that one. I'm fine with that. It doesn't matter. This one doesn't need to be creased, so I'm not too worried about that. It would have been nice if it was, but it doesn't matter. It doesn't matter. I think as I raise these surfaces up, it should fold still in that region. If it doesn't, I might have to play around with that. I wonder if it's because this point sort of curves around. Let's just see what happens if we bring this point. Oh, don't crash. Don't crash. Thank you. Let's just see what happens if we bring this point up slightly. I don't think it's going to like that. I think the crease might be failing because this edge sort of comes around and it starts to dip down before it hits this face here, or this edge here. I don't know, but we'll see what happens. Let's crease again. You do get pretty poor feedback with T-splines. When it says something's failed, it's just, you know, it's not the best. Perhaps that, okay, maybe that is where it's failing down there. Okay. Why though? Why for you don't like it? I mean, if you look at these edges as well, like the edge of the faces, you've got these sort of squiggly joining lines here. That makes no sense. I think that's just a graphical bug with Inventor. The faces themselves are actually perfect. They all meet at a single point. They don't behave like this. So that's not really any indication of it being at fault. But I don't know what I can do with this point here to kind of make it any better. We can try and just tweak it slightly, just pull it around a little bit, maybe raise it up. There. I don't know. This is going to be the last attempt at creasing it. If this one fails, I'm just going to leave it. Nope, doesn't like it. Okay, we'll just leave that one. But that's the main bulk of the surface is complete. So I can finish the freeform and then just turn off some of the stuff now that I don't need to see, and I'm going to save it as well. So we can turn off that. We can turn off the image, and yeah, that's pretty much the finished F. So we'll go back into form. Let's chain select these edges. So basically what I want to do is raise this series of faces there and this series of faces in here. So there's a couple of techniques you can use here that Tanner shows in his Fusion 360 tutorial, which work in Inventor. If you go to Edit Form, click an edge or click a face, hold down Shift and then double click the face next to it. It chain selects all those edges, which is really nice. It's really, really nice. I love that. And then we're going to pick up all of these and we're going to look side on, and we're going to pull up by, let's say, 20 mil. We don't want to put it up too much because it'll start to look a bit out of proportion. There you go. So yeah, that crease in that line there didn't really matter. It's still left a kind of a blend line in there. You can see that it's dipped there's a canyon in there, which is how I was intending it to be. So we've got a gradient running down from this face, we've got a gradient running down from that face, and then we've got this sort of hard section of faces falling off from that flat region, that flat raised region there. So there's a couple of things you can do from this point. You can, if you want to convert this into a solid, at the moment it's still a thin T-spline set of surfaces. So there's a couple of things you can do. You can thicken them. So you can say thicken that bunch of faces and then give it a thickness, which I guess that just depends on what you're doing. I mean, there is no right or wrong answer at this point. It doesn't exist, so it's all conceptual. But if I was to say 5mm, it'll just offset each one of the faces by 5mm and convert it into a solid, which will look a little something like this when it finishes thinking about it. Well, I suppose, is that 5mm or is that just not going to work? But it thickens the faces kind of normal to each face. So each thicken is perpendicular to the respective faces. So another option you can do is thicken it down an axis. So you can just say thicken it down that way. And you'll get a different result completely. You can see now it sort of falls off down the z-axis rather than perpendicular to each face. So that's one option. But that's not going to give you a filled solid, which is what we're after. So we're going to finish the freeform. And what we're going to do is we're going to use some sort of non-freeform techniques now. We're going to do a 2D sketch on our bottom face, not the XY plane. It's going to be on the face that all the surfaces were generated from. So that's essentially the floor. So a new 2D sketch on that surface, and we're going to project geometry. We want to project all the edges of the F down onto this work plane. Now, this is where Fusion can do something that Inventor can't do. Fusion, you can use project geometry, and you can project the entire body down onto the sketch. That was nice. I loved when I saw that. I was like, yeah, it's good. With Inventor, you can't do that. What you've got to do is just go around each bloody edge, and you've got to click them all separately, which is annoying as hell. But it's, you know, that's the thing with Fusion, because Fusion's newer. It's got a newer engine. The Fusion guys, they can design Fusion based around some of the things that Inventor's actually lacking. They're in Fusion and Inventor. They're at the same market. They're aiming for the same market. Different price points completely, but it's the same market. So Fusion can actually capitalize on a lot of the things that Inventor can't do. And it's actually doing that in some regions. So there we go. We've projected the F around, and we've got the F in a 2D sketch. And what we're going to do now is extrude that new profile up, but we're not going to do it as a solid because that would just completely swallow everything we've done in the freeform. We're going to use a surface, and we're going to extrude. Make sure it just goes higher than the F, higher than the top face on the F, and okay on that. And then finally, the final thing to do is a sculpt. So what sculpt is, I've actually already done a tutorial on sculpt. Sculpt works like pouring water into the surfaces. It looks for watertight regions, and wherever the water will fill up, that's where it'll create a resulting solid. So if I sculpt this, and then the bottom plane, you can see the water region that would fill up is this region here, which is exactly what I was going for. And there's your Fusion F in all of its magnificence. Be blown away by the turbulence of my magnificence. Well, Tanner's actually, it's all credit to Tanner. You might be thinking, well, it looks shit, Neil. It looks absolutely gash. Well, yeah, it is, but that's where you just apply some visual styles so you make it look realistic. You can change the color of it, so you can apply a texture from the appearance library. Let's say, I don't know, nylon 6. You can edit that texture, go to nylon 6, edit that, and then you can put in the Fusion RGB values, which Tanner's got in his video. I can't remember off the top of my head what they are, so I'm going to guess at 248, 136, 40, 46? I don't know, that's about orange, that'll do. And then we can OK on that. And if you want to just sort of play around with other regions that we're not necessarily looking at on this tutorial, like highlights, you can change that. Do you want it to look metallic or non-metallic? Do you want to put a bump map on it, make it sort of dimpled? You can play around with all that if you want to. And my voice is going. Right, so let's wrap this up. So there we go, we're almost done. Final things to do, put the shadows on. So you've got some ground shadows and some object shadows. Put the reflections on and change it to perspective mode. We're basically just building up to a ray trace render here. So we're going to change it to grid light. We're going to then edit grid light and then enable the scene image, save that. And then we're almost ready to hit the final go button, which is ray tracing. And that's us done. High quality. This is where my screen capture software might sort of shit its pants a little bit, because the ray tracing uses 100% of all CPU cores, and my screen capture software needs a lot of that juice. But there you go. That's the Fusion F modeled in Inventor, exactly how it's modeled in Fusion 360. Full credit again goes to Tanner Reid, our lovely millennial hipster from Autodesk 360. Thank you very much, Tanner. I doubt you ever will watch this. If you did watch it, let us know what you think. Let us know what your thoughts are between Inventor and Fusion. It's quite interesting to see what you guys think of Inventor and why you're doing what you're doing. Are you trying to steal our customers? Are you trying to move people from Inventor over to Fusion? Is that what you're trying to do? Own up now. Own up. But yeah, there you go. So it's a pretty good looking image. I would have probably actually in hindsight chosen a different material because you can't really see any glossy reflections around here because we've got like a metallic finish on it. So never mind. It doesn't matter. You get the idea. And that is the Fusion logo modeled in Inventor. Okie dokie. That'll do. Right. I'm going to wrap it up now. Thanks very much. If you liked the video, do slap a like on it. Remember, I've got a Patreon campaign going. Links in the video description if you want to help support the channel. If these videos genuinely do help you out, feel free to contribute on the Patreon. Any donations are hugely welcome because these videos do take up a lot of time and I'd love to have more time to do them and to do more of them and better ones in the future. So Patreon link in the description down below. Follow me on Twitter. I've now got a Twitter account and which it's sort of... I got about 50 followers in the first week, and then nothing since. But yeah, go and follow us on Twitter if you're on Twitter, and I'll see you guys in the next video. I'm now going to go and get a drink of water and cough my guts up. I sound like shit. Toodles.
Wherever you go with your babe, go with your babe.